ಎಲ್ಲಿಂದ ಬಿತ್ತು
Guys, can you able to see the screen? Hello.
ಇಲ್ಲ ಹಿಂಗ್ ಹೊಡಿತೈತ್ನಾ ಅದು ನಿಂಗೆ ಎಗ್ರು ಬಿಟ್ಟು ನಾನ್ ನೋಡಿಲ್ಲ.
Guys, can you able to see the screen? Huh?
Yes.
Okay, shall I proceed?
Yes, sir.
Okay, fine.
Yes, sir.
ಲಾಡು ಬಾ ಇದಾದ್ರೆ ಆಡೋಣ ಬಾ ಕೆಳಗಡೆ ಕುತ್ಕೊಂಡು ಆಡೋಣ ಬಾ ಇದೇ ಬಿಸ್ನೆಸ್.
Okay, fine, guys. In the last class, we have discussed. Okay, fine. So in the last class, we have discussed about MRA PSK. That is what the bandwidth discussion about QPSK, BPSK, and 16 PSK. So now in this session, we are going to discuss about how to plot a PSK signal. How to plot a PSK signal. Okay, fine now. So yeah, fine now. See now observe here. So now how to plot a PSK signal. Now, suppose if it is given for an by BPSK, we know how to plot a BPSK signal for a given binary bit stream. In the same way, now how we can plot an 8 PSK signal. How we can plot an 8 PSK signal given it is an a binary bit stream. Yeah, observe here now. So now what is the phase shift of M array PSK? We can write it as a phase shift of M array PSK is equal to what you can write. A phase shift is equal to a total angle is 360 degree divided by a number of symbols. A number of symbols. What is the number of symbols here? It is your M. So now in case of PSK, in case of PSK modulation, that is your BPSK. So the number of symbols used are it is 2, therefore phase shift is equal to 2 pi by 2, so that is 180 degree. So the total phase shifts are is nothing but what here it is 0 degree and 180 degree in case of what? A BPSK system. In case of BPSK system, the total phase shift here is the number of phase shifts used here it is 0 degree and 180 degree. Similarly, in case of QPSK system, the number of symbols used here it is M is equal to 4, and number of bits per symbol it is 2 bits per symbol. So what are the phase shifts used here? It is 2 pi. The number of phase shifts is equal to 2 pi divided by 4, that is pi by 2. So every phase shift changes with an angle of 90 degree. So the number of phase shifts here is what? It is 0 degree, 90 degree, again 90 plus 90, again 180 degree, then 180 plus 90, again 270. So there are total 4 phase shifts used in QPSK system. Again, similarly, if it is for an M array case, if it is M array system, so number of phase shifts is equal to, you can write it here, it is what? 2 pi divided by the number of symbols that you can write, it is 2 pi divided by M, and duration of each symbol. And what is the duration of each symbol? In case of M array PSK, we can write the duration of each symbol is equal to n times the duration of each bit, n times the duration of each bit. So TB here is the bit duration. So in case of BPSK, we know TS is same as what here? TB, because the number of bits used to transmit in BPSK case, that is your n value is 1 in case of BPSK system. And in case of QPSK system, the number of symbols used to transmit here it is 2. Therefore, TS is 2 times of TB. And in case of 8 PSK system, the number of symbols used to transmit, number of bits here is n is equal to 3. Therefore, the symbol duration TS is equal to 3 times of the bit duration. So that is what about your phase shift. Again, now observe here. Yeah, fine. Yeah, now please observe here. This is the question they asked in the one of the question paper. Observe here now. So I have taken this question. Let me answer for this question now. Please observe. What is the question they asked here is, please observe here. Define a bandwidth efficiency. Define a bandwidth efficiency. Tabulate and comment on bandwidth efficiency of M array PSK signals for a different values of M. So this is a question they asked in January 2019 for 6 marks bit. Now please observe here. See this expression, bandwidth of an M array PSK, we have already derived. I will use the same expression. Please look at the expression. We have already derived the bandwidth of an M array PSK. So what is the bandwidth of an M array PSK here is uh, bandwidth is equal to 2 times RB divided by log M base 2. See this expression we have already derived in the previous class. I hope you understood how we got this expression, the bandwidth expression. And what is RB here is bit rate is equal to 1 divided by TB. And what is M? M is nothing but the number of symbols. So what is bandwidth efficiency? The definition of bandwidth efficiency here is, in case of an M array PSK, it is the ratio of bit rate by bandwidth. It is the ratio of bit rate divided by the bandwidth. So that is what you just observe here now. That is the bandwidth efficiency rho. The bandwidth efficiency, the rho of an PSK is defined as the bit rate divided by, that is bandwidth, bit rate RB divided by the bandwidth, the ratio of bit rate divided by the bandwidth. Now please observe, now you can write from this expression, you can write what is RB divided by bandwidth can be written as, if you take the bandwidth on other side, if you take this log M based on left side, and if you simplify this, we will get here, what we will get here, it is log M base 2. So that is what, see from this expression, if you take, if you write it is RB divided by bandwidth means, you can write, so log M based on left hand side base 2 whole divided by, or you can write here it is 2. So this is what the bandwidth efficiency of an M array PSK. So what is the information from this? What you can get the information from this bandwidth efficiency is, you can observe. See, using bandwidth efficiency, you just observe here, whenever you increase the bandwidth, whenever you increase the bandwidth efficiency decreases. Whenever you decrease your bandwidth of the system, the bandwidth efficiency increases. That indicates what? The channel capacity increases. The bandwidth efficiency is nothing but what here? Your channel capacity increases. So that how that the bandwidth efficiency is increases by increasing the value of M. You can just observe, if you increase the value of M, that results what? Your bandwidth decreases, the bandwidth decreases. This decrease in bandwidth results the efficiency of the bandwidth increases. That indicates the channel capacity is increases. The channel capacity is increases. So now you just observe here. So that is what one bit is what here you just define what is a bandwidth efficiency. Bandwidth efficiency of M array PSK system, that is a one bit, and another bit is what here you compute what here, uh, compute the bandwidth efficiency for different values of M here. Now you just observe here, by making use of this expression, that is rho is equal to log M base 2 whole divided by 2. You can just observe here for a different values of M, that is when you take M is equal to 2, this gives your BPSK system. Again, when M you take it as a 4, it is QPSK, and M you take it as a 8 here, it is your 8 array PSK, and 16 array PSK, 32 array PSK, then 64 array PSK. You just observe here now, for this calculation, if you have a bandwidth efficiency rho is equal to 0.5, just observe here 1, 1.5, 2, 2.5, and 3. So what is the inference from this? When you keep on increase and you keep on increase your value of m, that results the bandwidth decreases, the bandwidth decreases, that indirectly increases your data rate, that you indirectly increases what here, the data rate, that is the channel capacity is increases, the channel capacity is increases. So that in turns results what, the efficiency of the bandwidth is increases, the efficiency of bandwidth is increases. So now again observe here now. So the second inference here is what? As the number of states, the number of states M of in M array PSK is increased, the bandwidth efficiency is also improved at the expense of error performance. See, the meaning of this sentence is what it says. If you increase the symbol rate, if you increase the number of symbols, of course that indirectly results increase in the bandwidth efficiency, but at the same time that also increases the error performance. That's a probability of error. So in order to maintain the minimum error probability, we need to have increase in the ratio of energy of the bit divided by the noise density. We need to increase the EB divided by N naught ratio in order to compensate for what? Increase in the value of M, increase in the value of 1. So now after this, now we just look at uh, how we can plot an 8 array PSK, 8 array PSK signal. Yeah, fine now. Yeah, now please observe here now. Suppose if it is given a binary bit stream, how we can plot a 8 PSK signal, 8 PSK signal for a given binary bit stream, Now observe here now. So we have already come across BPSK, QPSK system. That is what a number of phase shifts used in BPSK is 0 and pi degree, and in case of QPSK it is we have used it to 4 phases. And in when it comes to an 8 PSK, observe here, that is when m is equal to 8, so that results a 8 PSK, that is equal to 2 power 3. So we can have a number of bits used to transmit per symbol here, it is 3 bits per symbol. And the number of phase shifts, how many number of phase shifts, that is equal to total 8 phase shifts. There are total 8 phase shifts. Now observe here how we can draw the total 8 phase shifts here. Please look at here now. So now see, this is the phasor diagram for a pure sinusoidal wave. Observe in this phasor diagram. So when I draw normally for an 8 PSK, sorry, a QPSK case, observe what are the phase shifts we use for QPSK. See, that is one is 0 degree, a 90 degree, and 180 degree and 270. See, these are the 4 angles we have used for what? For QPSK case. So that indicates what? The total 4 phase angles, But in case of 8 PSK system, we should have an total 8 phase angles. That 8 phase angles are calculated, So you just observe here now. So now in between 0, 0, so that is what, if you just do 2 pi divided by uh, that is your m value, the total phase shift, you can write it is 2 pi divided by, so m value here it is 8, what we will get, so pi divided by, it is pi divided by 4. So what you can understand from this is, so there is a phase angle change of every 2 angles is how much? It is 45 degree. So now observe here the total 8 phase angles, how we can compute. So now first, if it is 0 and 0 plus 45 degree, what is the next phase angle here? It is 45 degree. Now this is 45 degree, and this is 90 degree, then again 90 plus 45, it is 135 degree. 90 plus 45, it is 135 degree. And 135 plus 40, it is 180 degree. And 180 plus 45, it is 225 degree. So another phase angle is 225 degree. 225. Again 225 plus 40, it is 275. Again 270 plus 45, it is 315 degree. 315 degree. So now please understand, there are total 8 phase angles. 8 phase angles are used in 8 PSK system. 8 PSK system. Now, so since here it is an 8 PSK, a number of symbols used here, it is 8, 8. Then we should have 8 distinct symbols. So 8 distinct symbols. So each symbols is what here? Each symbols is a 3 bit that I already told. So what are the 3 bits here? Starting from 002, 001 to dot up to where it is 1. So each symbol have a distinct bit stream that is from 002. So all 111. Now please observe here. Now how we can allocate that bit stream to your phasor angle. Now for a phase angle of 0 degree, we can have a bit stream 000. That is your a message symbol, say 1. And for a 45 degree, what is a bit stream? It is 001. Say message signal, I'll just say 2. And for a 90 degree, what is a bits phasor angle? It is 010. We can write a message signal M3. And for 135, it is 011. Say I'll say a message signal M4. And for 180 degree, we have a bit stream. It is 100. And say message signal M5. And for 225, it is 101. And say message signal M6. And for 270, say it is 110. And message signal is M7. And for 315, it is a bit stream 11. And message signal, say it is M8. Now you understood. So the total phase angles here, it is how many? That is 8 phase angles along with the bit stream. The total 8 distinct message symbols. So now with this information, we can able to draw the 8 PSK signals for a given binary stream that I'm going to discuss next. Yeah, fine now. Now please observe this. So this is very important diagram, how we can draw an 8 PSK system, 8 PSK system for a given binary bit stream. Yeah, observe here now. So this is very important. Please observe here. Yeah. Say for example, I have taken here. So this is the phase angle. This is a phase angle. See, consider. See, we have a bit stream of say 101, 101, 011, and it is 111. Okay, now please observe here now. So what is 101 bit stream correspond to? You can observe that in your phasor diagram. This diagram we also call it as an constellation diagram of an 8 PSK. See, this diagram we also call it as a constellation diagram of 8 PSK. 8 PSK. So now please observe here. So now say for example, if the given bit stream is, say here it is 101, 101. See, in case of 101, you can observe here, what is 101 bit stream corresponds to? Here it is 225 degree. What is the angle here? It is 225 degree. 225 degree. So now what is 225 degree? Now you just observe in a phasor diagram. In a phasor diagram, see, this is most important, please understand. In a phasor diagram, see, this is what your signal, a pure sine wave with 0 degree phase shift. I'll just extend one more cycle here. So where the 225 comes here, it is, see, this at this point, you just observe here, I have written all the phase angles with its amplitude levels, observe 0 degree, 45 degree, 90 degree, 135 degree, 180 degree, 225, 270, 315, and 360 degree. Observe here. So 101 bit stream corresponds to a phase angle of 225 degree. Now you should start. I'll just take here. It is from minus A to plus A. I'll just take. It is a plus A amplitude levels, and this is minus A. Now again, the amplitude levels at these angles. What is at these angles? It is 45 and 135. It is plus A by 2, and again at this levels, what is the angles here? It is minus A by 2, So now how we can write this? So you can write, so now observe here, now where the 225, the angle 225 is at this point, from here to again till the next 225. Now write a phase angle of what here? A phase waveform. You write, start from here, that is at this point 225 to the next 225. Where is the next 225 comes here? At this point, So write a signal. Now start from this point. Observe here, start from this point, that is at minus A by 2, to the one complete cycle. From where again? The minus at this point. So that is what your phase angle of 225 degrees. See, that I have clearly drawn here. You can just observe here now. That is for a bit stream 101. Sorry, this is 101, not 100. Okay, fine. Again, when it comes to a bit stream of 011, see what is 011 here? 011 is a phase angle corresponds to 135 degree. Observe here, where is 135? See, at this point, again from here to where, again 135 comes here till here. Again the 135 comes here till here. So now from here to here, you write the waveform. That is what I have written. Now starting from where? It is at from minus A by 2. It is from at minus A by 2 to that is one complete cycle to again at next 135. See, that is what this waveform. Again, When it comes to 1 1 1, so that is all bits is equal to 1 here. So what is a bit stream here? It is triple one. So triple one corresponds to a phase angle of 135 degree, 135 degree. So we can draw this 135 here. Now observe here, 315 phase angle is here. Again from here to the next 315 is here. From year to year, just observe here, from year to year you should draw the complete cycle. So I have taken where it is this point is at minus a by 2. Now you take it from at minus a by 2 to one complete cycle, again at from minus a by 2. So now you can write from here, start from minus a by 2. I'll just use another color here. So I'll just take it, say here, so minus a by 2, minus a by 2 to the next minus a by 2. See, this is what the another phase angle corresponds to what? A bit stream 311. Now at the receiver end, see, this is how at the transmitter end this binary bit streams are decoded coded into this phase angles, these waveforms at the transmitter end. At the receiver end, once the receiver receives this phase angle signal corresponding, that is mapped to your bit stream of 101, and this phase angle waveforms that is corresponding to map to 011, and this phase angle corresponding to map to 111. So at the receiver end, this waveform is mapped to a binary bit stream corresponding to the phase angles, corresponding to the base angles. Now observe here, see here I have written the all possible cases of an 8 PSK system along with the phase angles. Now there is an assignment. Please all of you please note down this. Anyway, I'll be sharing the material. So please all of you draw the phase angles corresponding to all these bit streams. So please all of you draw the phase angles corresponding to all these bit streams. Please write a waveforms corresponding to all these bit streams. So that is a assignment for you people. So after this, now I hope you understood how to draw a waveforms of an 8 PSK signal. Similarly, it goes for an 16 PSK. We have 16 different phase angles that can be drawn in the similar manner. Now I'll just take another problem here. Now please observe. So there is another problem. Observe here what he has asked in this problem related to your MRA PSK. Just look at here now what he has given here. See, in this problem you just observe. Assume that you are required to transmit FB, let's say frequency of 90 Mbps, the bit rate he has given 90 Mbps in an authorized bandwidth of 20 megahertz. Here he has given the bandwidth value, it is fixed. We need to use the same bandwidth only, that is 20 megahertz. This is fixed here. This is fixed. Now, what is the question here? Which modulation techniques would you consider and explain what is the reason for that consideration? Now please observe here now, since the value of the bandwidth it is given fixed and the bit rate is also it is given fixed, we need to find which M array PSK is suitable for transmitting this kind of signal. Just observe here now. So what we can write, a bandwidth, we can calculate what is the bandwidth of an M array PSK can be written here. See, this is similar to the previous expression, that is same as what here. So what was the expression of your bandwidth of M array PSK? It is 2 times RB divided by what we have used. It is log M base 2, correct? So it's the same expression only, you just observe here now. So here the numerator 2 as it is there, and this RB I can write it as 1 by TB. This RB I can write it as 1 divided by TB, that's why TB in the denominator. And this log M base 2, this log M base 2 is what here? The log m base 2 is nothing but what? It is your number of bits in a each symbol, that is your n. So I can write alternatively, both the expressions are same. That's the bandwidth of your M array PSK. So now from this expression, observe here, it is given that FB is equal to what here? It is 90 into 10 power 6, that is 90 megahertz, 90 megahertz. From this, we can calculate what is the value of your bit duration. What is the value of your bit duration? So by substituting this value, we can write TB is equal to what here? It is 1 divided by FB. So TB is nothing but what here? 1 divided by FB. You can write is equal to what? 1 divided by 90 into 10 power 6 seconds. 6 seconds. See, that is what your TB value. And what is the bandwidth? Here also given the bandwidth. What is the bandwidth value here is 20 megahertz. 20 megahertz is equal to 20 into 10 power 6. 20 into 10 power 6. So now for a given modulation techniques, the bandwidth must be what? A lesser than or equal to the actual bandwidth. Lesser than or equal to the actual bandwidth. What is that actual bandwidth is? Worst case must be equal or must be a lesser than that actual bandwidth. What is the actual bandwidth we have used here? It is 2 by NTB. 2 by NTB. So 2 divided by NTB, you can use this. Now, given it is a bandwidth, what is the bandwidth value here? Given it is 2 into 10 power 6, 2 into 10 power 6 is equal to 2 into, you can write n into 1. N is unknown here. See, this you need to compute because we don't know what is the n value here. So if you know n value, you can calculate what is the m value, so that can be find what is the suitable m array PSK here. So now you can write which is equal to what is the TB value. If you substitute TB is 1 divided by 90 into 10 power 6, 10 power 6. So which is equal to, now what you can write is 20 into 10 power 6. You take this into a numerator, what you will get? It is 90 into 10 power 6 into 2 divided by n. If you cancel this 10 power 6, 10 power 6 and 0, you can cancel this 2 and 2. So what you can write here, if you take n on left side, you can write n is less than or equal to 9. So what is the suitable value of n that can be achieved here? It is n is equal to 9. So what is that? N is equal to 9 means, what is that meaning? N is equal to 9 indicates what? What is n here? It is a number of bits used to transmit per symbol. Now means per symbol we are transmitting how many bits? It is 9 bits. Means what is the m value? What is the m value? You can write here. M is equal to what here? So m is equal to 2 power n, that is a number of symbols is equal to 2 power the number of bits. So we can write it is equal to 2 power 9. So what you can write here? It is 512. So what is the m value? That is a number of symbols used here. It is what? 512. So now what we can write here? So that is m array PSK means, what is a PSK now? Here it is becomes a 512 array PSK is suitable for transmitting at the speed of what? A 90 Mbps in a given bandwidth. How much? It is 20 megahertz. Guys, I hope you understood this problem along with how to plot an 8 PSK signal given it is on binary stream. In the next session, I'm going to discuss the QAM. I'm going to discuss the quadrature amplitude multiplexing. Okay, so thank you guys.